Alright, I got my Ferrofluid all mixed up here. I did not, in the sample video that I watched, the gentleman used ink toner, and I did not have that at my disposal, but I did have some iron fillings. So I used a whole container, like 12 ounces of iron fillings, and probably ended up using a half a cup or so of vegetable oil, and it's still, you don't get that perfect consistency. It still separates, so you give it a stir every now and again. I'm totally not in front there. But it is just as cool to see this stuff work. I don't know how the lighting is here. I have to put some in my flask there. Very cool. I do find it interesting when you put the magnet on the bottom, how much oil just sits at the surface, and how much more difficult it is to stir, amazingly enough. Yeah, let's just screw around here. Oh, that's pretty slick. It's still a little thick there. Sorry, this is a really difficult one-man show here. I'm actually going to throw a little more oil in there and just see if that changes anything. Oh my man. Right. That is so cool. Yeah, this looks, it's definitely better out of the beaker to see. That is so weird. Well, I hope this is viewable. I'm having a heck of a time paying attention to both here. But same deal. You apply the magnet and you get all these little needles branching off of the fluid. I have no idea why, but I'm going to figure it out. Okay, so we got some answers here. It's supposed to make a ferrofluid. By definition, a ferrofluid is made with nanoparticles, usually in the range of 1 to 100 nanometers. I did not make a ferrofluid. From the best I could find, the particle size of the iron filling that I used was about 40 mesh, which is 0.42 millimeters, which is a significant factor. I mean, that's a factor of, 10 to the negative fifth or sixth. It would need to be smaller by a factor of 10 to the negative fifth or sixth to be in the nanoparticle wheelhouse for a ferrofluid. Technically, no, the toner wasn't either. It was a much less significant difference, but even today, like the smallest toner particle size is about 2 microns, which is still 20 times larger than the upper end of nanoparticles used in ferrofluids. Beyond that, what I would have made with my iron filling is a magnetorological, yeah, $1 million word there, fluid. And yeah, even doing it, I noticed when the magnet was applied, like the viscosity of the fluid, it was far more substantial, which is a common characteristic of an MR fluid. The spiking still happened. It wasn't nearly as cool, and just getting back to the viscosity, when you looked at the video of the toner and the oil, the guy's spinning the circle spikes, and it's just acting like independently of everything else while still maintaining that shape. That wasn't going to happen for me. It's still spiked. This circular dome shape of spikes, and that really, much like the ferrofluid in the video, when magnetism or magnetic field is applied to these to iron, they essentially, it magnetizes the iron, so they stack on each other. But even though they stack on each other, they're still repelled by each other, because you're putting, north and south poles end to end. Well, they're still next to each other, which pushes them apart. So that kind of creates that phenomenon of the dome spiking, and that is all I have to contribute to ferrofluid information. Thank you.